Welcome to EDU World Space.
Problem 3.95. In this problem, we have to calculate equivalent force couple system at point A, that is origin of this system. So for the calculation of equivalent force, since there is only one force is acting on the system, so the force itself will be the equivalent force about point A. So we can write this force in its component form as this 150 Newton is going to make an angle 35 degree with vertical axis. So we can write it as the force. So the equivalent force will be R is equals to 150 cos 35, and this will make in minus j cap direction, and plus 150 sine 35, and this will be in negative k cap direction. It will have no x I cap direction since it is in yz plane. So R comes out to be minus 122.873 Newton j cap minus 86.036 Newton k cap. So this is the equivalent force that is acting at point A. Now for the calculation of equivalent moment at point A, we can write it, since no moment is acting on the system, so we can directly we have to calculate the moment because of this force, and that will be position vector of the point of application of the force. So this will be d with respect to the point about which we have to calculate the moment, that is the point A. So position vector of point D with respect to point A, its cross multiplication with the force that is present there, and that is, let's say, F. So this F is here 150 Newton. So we can write the position vector of D with respect to point A. We have to first calculate that, and if we go for the calculation of position vector of D with respect to A, then we can see here that in x direction it is at a distance of, this is 200 mm and this is 20 mm inside, so this will be 180 mm in I cap direction. So if we convert it into meter, so we can write it as 0.18 meter I cap. Now we observe here that it is at a depth of 120 mm in y direction, so we can write it as minus 0.12 meter j cap. Now if we talk about the k cap direction, so it is at a distance of, this distance is 60 and this distance is 40, so distance from x axis will be 100 mm. So we can write it as plus 0.1 meter k cap. So we can reuse this expression of position vector of D with respect to A, that will be 0.18 I cap minus 0.12 j cap plus 0.1 k cap, and its cross multiplication with the force vector, that is minus 122.873 j cap minus 86.036 k cap. Now we can solve this by using a determinant method. So this is I, j and k. This will be 0.18 minus 0.12 and 0.1, and here the x component is 0, j component will be minus 122.873 and its k component will be minus 86.036. So now we can expand this determinant about let's say if we expand about I cap, so its terms will be minus, first we multiply this, so this will be minus 0.18 multiplied by 122.873. all right, it's an error. If we go for the I cap coefficient, so we have to neglect these two, so these four 2 by 2 matrix, so we have to solve this. So minus 0.12 multiplied by minus 86.036 minus 122.873 multiplied by 0.1. So this will be the I cap component. If we go for the j cap component, So we have to neglect these two. So we have to multiply these two lines, and it will be 0.18 multiplied by minus 86.036, and 036, this is the J cap coefficient, and if we go for the K cap coefficient, so it will be 0.18 multiplied by minus 122.873. The other component will be 0. So we can solve this. So it comes out to be 22.6 Newton meter I cap plus 15.49 Newton meter J cap minus 22.1 Newton meter K cap. So this is the expression for equivalent moment that is acting at point A. So this is the answer for equivalent moment, and this is the answer for equivalent force.